last time, test corrections. If you're going to make test corrections, when's your deadline? Monday. So make sure Monday you have test corrections in if you're choosing to do so. JMC looks really good right now. You guys are doing an awesome job, so keep that up. So 10.2 here, we'll get started. I think 10.1, you guys feel pretty good about that stuff?
Yep.
Tangents, lines of tangents, secants, all that stuff. So today what we're going to look at regarding circles is called finding arc measures, and this is really pretty much an easy concept. Okay. Question today. How many want to read that? Who wants that first today?
How are circular arcs measured?
How are circular arcs measured? Okay, so we're going to have to figure out what an arc is first, but our goal is to answer that question. We're going to find arc measures, we're going to identify congruent arcs, and we're going to say that circles are what?
Similar.
Similar, okay? All circles are the same what? All circles are the same shape, but not necessarily the same
size.
Okay, so that would make them similar, all right? Lot of vocab today. Let's roll. First one today. What is it? Central angle. I need a volunteer to read that definition for me.
A central angle of a circle is an angle whose vertex is the center of the circle. In the diagram, ACB is a central angle of a circle.
Okay, so let's form this. ACB is going to be my central angle. So I'm going to start with a circle here. This circle is going to look like the following. I'll do my best. There it is. ACB is my what? Okay, I'll do my best here to move this angle a bit if I can. I'm off a little bit, aren't I? How's that look? Does that look like it's in the center there, kids? Might call this A. Call this C. Call this right here B. All right? ACB is a central angle. A central angle is basically when the angle is formed at the center of the circle right here, okay? So keep that in mind, all right? Now, minor arc. You're going to hear two terms, minor arc and major arc, all right? What 2 points are on the circle? Not in the circle, but on the circle. Okay. If I wanted to go from A to B, there's a short way to go and a long way to go, all right? Yeah. If ACB is less than what, kids? Then the points on circle C that lie on the interior of ACB form a minor arc. So the minor arc basically is the short way from A to what? Okay? Minor arc is going to be the distance between the points, all right? It's going to lie right in here. So this part right here, what kind of arc is that right there between A and B? Is that the minor arc or major arc? The minor arc, okay? So what's that make a major arc, kids? Where's the major arc going to be?
Like the other way around.
Other way around, taking a long way around. That's the long way from A to B. Okay? Guys, if a minor arc is less than 180, then what's true about a major arc? Not less than 180, but more than 180. I'll show you how to find that, okay? I'm going to give you a little hint right up here, kids. Major arcs are found by taking how many degrees are in a whole circle? Okay, the major arc is found by taking 360 degrees minus the minor arc. Maybe you want to put that in there. We'll talk about that more in some core concepts here in a second, but just kind of forward thinking here. All right. What's a semicircle? You guys have heard of semicircle before. Half a circle. So if I'm talking half a circle, what's the arc measure then?
180.
180 degrees, because it's half of how much, Eli?
360.
It's exactly right. It says right up here, a semicircle is an arc with endpoints that are endpoints of a what? Diameter. Okay, so if I drew a semicircle, I'll do my best. That's what it looks like. Okay? The arc is how many degrees for a semicircle, kids? It's 180 degrees of measure. Okay? All right. So we're going to talk about measures of minor arcs and measures of major arcs today. I'll read the first one. It says the measure of a minor arc is the measure of its central angle. The expression measure of AB is read as the measure of arc AB. I want you to put like a little arc up here above AB, okay? The major arc, I'm not really going to worry about this too much because we kind of talked about this. We don't really need any visuals for this. The measure of the major arc is the difference of what? 360 and the, isn't that what we said right up here, kids? So maybe I just draw an arrow from here to say, read that. Okay. How about adjacent arcs? Volunteer to read adjacent arcs for me.
Two arcs of the same circle are adjacent arcs when they intersect at exactly one point.
Okay, and that goes on to a definition on the second page. It says you can add the measure of what?
You can add the measure of two adjacent arcs.
Okay, so let me show you what they're talking about there. I'm going to stay on the first page and make a diagram of this. Let me blow this up quickly. So in that bottom right down here, kids, this is what you might see today when we talk about arcs. Again, we're talking about circles and then part of the circumference on a circle. So here maybe my circle again, okay? And maybe I pick a central angle to go here to here and then to here, okay? I might label this A, B, and C. And I'm going to put my middle as P here. Okay? Give me the name of one arc up there, kids.
AB.
AB. Give me another arc.
AC.
A to C is another arc.
BC.
BC is another arc, right? Okay. How about two adjacent arcs? Arcs that share a same point.
AB.
Doesn't this arc right here, AB, share a point with? Okay, so what I'm going to say right here for my adjacent arcs right here, I'm going to write it like this. Arc AB, you put that little arcing sign up there, is, what's the word, kids? Adjacent to what? To arc BC. Okay. They're adjacent because they're right next to each other. This arc and this arc, which point do they share, kids? They share B. Okay. All right, definition-wise, I think we're doing a good job right now. My first question, anybody need more time for diagrams on the first page? Anybody need more time for the illustrations? Congruent circles, kids. What's congruent mean? Everything we've talked about in math, geometry related. What's the word congruent mean? Equal. Same shape and same size. So if I'm talking about congruent circles, it says two circles are congruent if and only if they what? Have the same radius. That means they're going to be the same size. Okay. Then congruent arcs. Two arcs are congruent arcs if and only if, and this is kind of a biggie, if they have the same what? Same measure, and they are arcs of the same what?
Circle.
You can't have an arc measure in a great big circle be 90 degrees, and then in a really tiny circle have an arc measure be 90 degrees, and say, oh, they're congruent. They're not congruent because they come from what? If one circle is this, one circle is this,
It's a different circle.
it's a different circle. The only way arcs can be congruent is if they are of the same circle and the same arc measure. Okay? And then similar arcs. We'll talk about similar arcs. This is going to be kind of a new one, and it's going to be kind of tough for us. Two arcs are similar arcs if and only if they have the what? Okay, so we'll talk about what's congruent. We'll talk about what's similar. You guys ready to roll? Okay. We've kind of talked about this already. Core concept. Measure of a minor arc, measure of a major arc. Sketch in two circles here, kids. And then maybe make a central angle kind of like so. Kind of the same thing in each one. I'm going to label this AB. And I'm going to do the same thing over here. Label this AB. What do you want to name the circle, kids? What letter? Let's call it U today for the U. How's that sound?
Sure.
All right. Measure of a minor arc. Where's the minor arc in this one? That's the minor arc right there. So where's the major arc?
The other way around.
It's the long way around, isn't it? Okay. I have a question. If the minor arc in each of these was, let's say the minor arc right here is 30 degrees. What's that make the major arc? Not 130. How many degrees in a whole revolution again, kiddos?
30.
Yeah, we would take 360 minus what?
30.
330. So the minor arc was 30 degrees. The major arc would be larger. Okay. So here's what I want you guys to do. It says find the measure of each arc of circle C where AB is a what, kids? If you have a straight line as a diameter going through there, that central angle, it's a diameter, is a straight line. How many degrees in a straight line again? 180. Okay. Kids, help me find the measure of mark AD. What is that? Measure of arc AD right here. What's that angle? It's simply 65 degrees. Oh my God, we get to dab today. Oh, so cool. Everybody get this answer right. I want you to dab. This one here says the measure. Why are there 3 letters up here, kids? This is saying start at D, make sure you pass through what? A, and end at what? So if I'm dabbing, all right, I'll stop. If I go from here to A to B right here, kids, this is basically telling you to go clockwise or counterclockwise. Counterclockwise, right? So how many degrees do I have from D to A first, kids? And then from A to B, another what? 180. So I would do 65 plus what here, kids? Oh, help me out, kids. My north of Highway 3 math skills are on break today. 200 and? Very good. Okay. How about B to D to A? Start at B, end at A, and make sure you pass through D. What do you think there? 180. It's a half circle. Okay. If I ask you guys to find arc measures, can you do it? That's pretty easy, isn't it? Okay. How about this one up here? How about DCB? How about this one right here, the minor arc for D to B, in other words? 180 minus 65 be 115 in there, right? Sometimes it's beneficial for me to go into the circle and just label them. Say, well, if this is a straight line, over here is 180 degrees, and I know that this would be 180 minus 65 in here, which is 115 degrees. That helps me a lot if I go in there and label them all and then start adding them up. Okay, Leighton?
So what if the major arc and the minor arc are the same, by the same degrees?
So the only time that will happen is if you're dealing with a semicircle. One would be 180, one way, 180 the other way. Okay? And that's why they call it a semicircle. So there is no major or minor arc to a semicircle. They just say the arc measure is 180. Okay? Because that's where they would be the same.
Okay.
And I think definition-wise, if I go back to this, Leighton, and that's a great point that you bring up. The semicircle is an arc with endpoints that are endpoints of the diameter, meaning 180 degrees this way, 180 degrees this way. So you could also note in here that the arcs would still be, yeah, I think we noted that already. Okay? All right, are we ready for page 3, guys? I want you guys to see if you can figure out example 2. So try that on your own. See what you come up with. Once you have them, check with a neighbor around you, see if you agree. You guys have them? Okay, how about a volunteer for SQ? Raise your hand, please. How many went in here and labeled all these first? Maybe that's a better question. What did you label this angle as? 90. How about right here? 100 and... Okay, PR would be 180, but wouldn't I take 180 minus 35 to get POS? Dabbing POS today. I'm done. I can't do this again. Oh, that was funny. How many went in there and labeled those POS angles? Did you label the angles first?
I did.
Okay, maybe that, I mean, that helps me. I'm not telling you you have to do that, but boy, that sure helps me when I do that, okay? How about S to Q? What'd you guys come up with then?
1.5.
Okay, take the minor on this, so 125 degrees, I agree. Okay, how about R to P to Q?
20.
Okay, so R to P to Q. You gotta be careful on this one. Which direction do I have to go, kids? R to P is how much already? 180 plus how much more to finally end up at Q? So what would that be? Is this a minor arc or major arc? Yeah, it's over 180. Okay, how about PRS? P to R is how much, kids? 180 plus go into S, another 35. What'd you guys have for that? 215? What do you guys think? You guys okay with that? Okay with that? All right. How many had those, by the way? If you made a mistake, give me a show of hands. How many are at least on board with me now? Excellent. Okay, excellent. All right, let's find some arc measures, kids. Right here it says in example 3, a survey asked people how many minutes they spend doing what? Brushing their teeth. Oh my gosh. 1 minute is dominant. Whoa!
How long are you supposed to?
I don't really know.
2 minutes.
2 minutes? Survey asked people how many minutes they spend brushing their teeth each morning. The circle graph shows the results. Find the indicated arc measures. Okay? For how long did you brush your teeth? So how many people or how many degrees in the 1 minute part, kids? 145. Now obviously we could turn this all into percentages. How many degrees are in a whole circle? I mean, we could turn these into percentages eventually, and we're not going to do that, but I mean, obviously if I look at that chart, what's the biggest fraction of time up there? 1 minute. No wonder dentists are always making money. We're only brushing our teeth for a minute, majority of us. How many are 1 minute brushers? Quick in the morning. How many are like a 5 minute brusher? My wife, I swear, she's got to have the cleanest teeth in the world, Bree. She's in there like 10 minutes brushing her teeth. And guess who has all the cavities in the family when we go to the dentist? She does. Yeah, she does. It's funny. All right, here we go. It wants us to find the measure of arc A, B, C. Okay? That's pretty easy, isn't it, kids? What plus what? 120 plus what? Which is 202 degrees. Okay, you guys are on your own, so B, C, and D. Go ahead. All right, anybody have A to C to B? 240 degrees. A couple ways I can do this. If I went the major route, I could take 145 plus 13 plus. But what I could have also done is taken 360 and subtract out what? That would work also, okay? Who has BD for me? 95 degrees, I agree. How about my last one? So I'm going C to what? B, all the way around D. How'd you handle that one?
Isn't it just 360?
Yeah, we're C. Arc CVD includes the pink section, the purple section, and the green section here. So couldn't I just subtract out this yellow section? How many degrees is that yellow section right here? Couldn't I just do 360 minus 13 here for that? 300 and... Guys, you getting this arc measure stuff okay? It's pretty simple, isn't it? Told you if you can add and subtract, you will be what?
Smart.
Fine today, okay? All right, anybody need more time on that page? Okay. Let's get our last page done here. So a couple theorems that I need to make sure we understand. I think if there's anything that could pose itself as maybe a challenge, it might be this section. So I'm going to put a little star by this right here. Okay. Theorems. First theorem I have up there today, kids. Congruent circles theorem. It says two circles are what, kids? If they have the same radius, okay? Remember that, okay? It's really saying circles are only congruent if they're the same side, right? Okay, somebody want to read this congruent central angles theorem for me?
In the same circle or in a congruent circle, two minor arcs are congruent if and only if their corresponding central angles are congruent.
Okay, so let's talk here real quickly, kids. Up here in example 4, it says identifying congruent arcs. It says tell whether the red arcs are congruent, explain why or why not. First of all, is the measure the same, first of all, of each arc? There are two arcs, G to F and then H to, is that a C right there in your notes? H to C, okay?
It's an A. It's an E.
Is it E? Okay, let me fix that a bit. So GF and HE.
It's not.
Anyway,
No.
okay, we know it's E. Good. Bye. Okay, first of all, what's the measure of arc GF?
110.
What's the measure of arc HE?
110.
Question becomes, are the arcs congruent or not, though? By measure, they are the same arc, right? But are they of the same radius? Are they of the same circle, in other words? Okay. So the question becomes, tell whether the red arcs are congruent. The answer in this one here is no, because they, I'm just going to say the circles aren't the same size. Is that okay? Is it okay if I say the circles are not congruent? Are you guys okay with that? And guys, think of it this way. Could I take this inside red arc and lay it on the outside red arc and have them be exactly the same? Would this arc fall completely on this one right here, or would it be short? It'd be a little bit short, wouldn't it? Okay. Now, here I have arcs of the same circle. What's this arc measure have to be right here from S to R? 65 degrees right here, right? So the question is this arc in red right here the same as this one? Well, what's true about their arc measures in terms of degrees, kids? They're the same. The arc measure is both 65 degrees in each case. Are they of the same circle?
Yes.
So they're part of the same radius. So are these congruent?
Yes.
Yes, because the arc measure is the same for the same circle, right? And yes, they are going to be congruent. So I should say that right here. Yes, congruent, because the arc measure, 65 degrees for SR and 65 degrees for PQ, are the same arc measure for the same exact circle. They're basically on the same circumference, aren't they? Okay. How about C, JK and MN? Congruent or not congruent?
ln is 12. Okay, it's 6. That's
Twelve
just,
is good,
okay,
that's
so-
Let me ask the question first. Are the circles congruent?
Yeah.
Yeah.
Because what's the radius on the left?
6.
What's the radius on the right?
6.
So the circles are congruent.
Yes.
Yeah.
So if the circles are congruent, the arcs will be congruent if and only if the angles are the same. So I'm going to say right here, well, we know the circles are congruent because the radius is equal to what in both? So the radius is 6 in both. How about this angle for JK? What's the central angle for JK? What's the central angle going to be for MN? 90 also. Are the arcs the same? Yeah. The measure of the arc angles are both 90, so the arcs are both 90. Arcs are 90 degrees. So I'm going to say JK, arc JK, is congruent to arc what, kids? Okay. Questions do you have? Okay, what I'd like you guys to do is to peer assess yourself. So there's a short little practice down there. When you get done with it, check with your neighbors. Make sure you feel good about it. I'm going to tell you, get started on 10.2 online. And don't forget your test corrections are due for Monday.